Hello everyone. Let's discuss about log-based protocols. See, generally, when you consider transactions will be performing parallelly, concurrently, parallelly to each other. That means one transaction will start. Let us suppose it is T1. T1 will start. When T1 is continuing itself on the other side, there are chances that T2 also starts. So we can't say that only after the completion of T1, then only T2 starts. That means the transactions can work parallel to each other, concurrent to each other. And both the transactions can work on the same data item. That will lead to certain problems. That means both the transactions T1 and T2, both of them can work on the same data item. Let us suppose there is a bank account, a joint account. Okay. Uh, Let me suppose X and Y are two persons who are having joint account. X is, first of all, X has started his transaction of inquiring the balance. In the meanwhile, when he is about to close, let us suppose Y also is working on the same bank account by withdrawing the money. So there will be a problem of having wrong data. So in order to prevent such problems, we will be using log-based certain protocols. One of them is called as log-based protocols on the transactions which are working on the same data item. So first of all, what is a log? This is a mechanism which is used to control concurrent access to a data item, because both the transactions are working concurrently, parallelly, and both of them are acting on the same data item. So by using this log alone, we will be able to control such access upon that particular data item. As such, when there is a lock on one data item, the other transaction cannot work on that particular data item. Only after that particular lock is released, only then the other transaction can start its execution, can start its performance on that particular data item, because both the transactions are working on the same data item. Okay, so this lock is particular mechanism that is used to control concurrent access to a same data item. So when you consider log-based protocols, you'll be having two types of logs. They can be executed in two modes. One is a shared mode and the other one is exclusive mode. Why these different modes have occurred in these log-based protocols means, because see, suppose there is a transaction T1 which is working on the data item, which is used to just read the data item. Okay, and there's another transaction T2 which is trying to modify that particular data item. Then in that case, if the transaction T1 which is just reading the data item, and suppose let T2 is also working on the same data item to read. When these two things are in read operation, are performing the read operation on the same data item, and if at all, if lock has to be applied on the data item, what happens? Transaction T1 will lock that particular data item for a time period until it finishes its execution. That means its operation of reading. It will not release the lock. As such, the other transaction has to wait just to read the same data item. Reading the same data item is nothing but you are knowing what is the value there. That's it. You are not going to modify anything. Okay, that is just called as reading. Just to perform such a read operation, what we are trying to do, we are trying to log particular data item such that it is leading to waste of time during the transaction process. Okay, so in order to prevent such problems, even while applying logs, you will be applying logs in two different modes. Those two different modes are said to be exclusive mode and shared mode. Okay, so when you say that a data item is locked in an exclusive mode, then we can say that the data item can be both read as well as written. Okay, the data item, we can perform both the read and write operations on the data item which is in exclusive lock. So exclusive mode, if at all, if the lock is in exclusive mode, we'll call it, or we'll write it as X lock, we'll call it as X lock. And this is written as lock X. While writing it in terms of transaction, you'll write it as lock X instruction. Okay, similarly, you have another mode of lock that is called as shared mode. In this shared mode, data item can only be read. You can perform only the read operation. When the data item, when suppose the data in transaction T1 is in shared mode, then it can only be read. You can't modify that particular data. So shared lock is requested using lock -s instruction. This is how it is given in the instruction wise. Okay, so these locks are used, are made to, for what purpose? For concurrency control manager, in order to control the concurrency, because it is being used by the same data item is being used by two different transactions. Is this clear? So whenever a log based protocol is asked, we should know about shared mode and exclusive mode of logs. So what happens when it is a shared mode log, and what happens when it is exclusive mode? Let us suppose always log will be applied on when there are two different transactions. Yes. So let us suppose this is transaction T1 and this, let us suppose this is transaction T2. Now the log compatibility matrix between T1 and T2 on the same data item based on their modes, that is shared and exclusive, is something like this. See, when T1 is in shared mode, T2 can be in shared mode, and T2 is also in shared mode, then that is fine. You need not have any problem here. Okay, that means if T1 is acquiring a shared log on a data item, then T2 also can acquire the shared log on the same data item. Then there is no problem. But whenever there is exclusive log on any data item, let us suppose T1 is acquiring exclusive log on data item X, then in that case T2 can't even acquire shared log or exclusive log on the same data item. That is what is log compatibility matrix. Wherever you find exclusive log, because what are the things which can be done in exclusive log? Those are both the read and write. Yes. So when both the read and write are being performed, the other shared mode, let us suppose, which is used only to read, can't read the data item, as well as the other exclusive mode, which is used to both read and write, also can't be used for reading the, can be used for acquiring the log upon the data item. This is what happens. So whenever a log based protocol is applied upon the transactions, log compatibility matrix is a must. We should understand what happens, which type of logs can be given at what times should be understood. Okay, the next thing is, if you look at some example here, see, let us suppose you have a transaction T2. This transaction T2, first of all, it is having shared log on a data item A. So when there is a shared log, what it can do, it can only read the data item, and then let us suppose, according to this particular transaction which is being performed, you are unlocking, you are releasing the data item from the lock. Okay. Next, on data item B, in the same transaction on data item B, again you are giving shared log. You are reading it, because in shared log we can only read. So we are reading the data item B and B unlocked. Finally, we will be getting the values. We are displaying the sum of those values. Okay. What happens here is, this is normal transaction. There is nothing like concurrency over here, that is different transactions working on different data items. Okay, there is one transaction which is working on different data items, but serially one after the other. Okay, we can't just specify that this is able to provide us serializability. What is serializability? Serializability is a process which determines that when there are two transactions within a schedule, then that schedule, if it is not a serial schedule, because transactions will work in concurrency, so if it is not a serial schedule, then in that case we should try to understand whether it is a serial schedule or not. If it is not a serial schedule, we should try to convert it into serial schedule. See, that is called as serializability. The process of conversion of non-serial schedule into serial schedule is known as serializability. Okay, so by using various protocols like lock based protocols, we will be able to achieve serializability for the transactions. Is that clear? So when that is the case, this example alone is not sufficient to determine that there is a serializability, because what happened here, we are just providing shared logs which are only used for reading, and you have only one transaction which is working on two different data items. And when this process is going on, the locking upon these data items and unlocking upon these data items and performing read operations on these data items are being done one after the other and not in parallel. So this example alone is not sufficient to determine or to explain about serializability, because we can't say this is a non-serial schedule here. Okay, so what we do is we should go for other example. We'll try to that. First of all, a locking protocol is nothing but a set of rules. Whenever you say it's a protocol, it's nothing but a set of rules. What it should be done in locking protocol, it should follow all the transactions while requesting and releasing locks. Okay, locking protocols restrict the set of possible schedules. That is why you will be able to attain serializability. Okay, so let us go for this particular example, that is T1, and you have two different transactions, and these two different transactions will be working on two different data items. So we'll see what happens here. So if you can look at transaction T1, it is working on it. First, it is working on a data item called as B, which is nothing but an exclusive lock. Okay, so B has attained an exclusive lock now. So when B has attained exclusive lock, it means that it can read and write here. As a result, first of all, I am reading this particular value, and then I am writing nothing but I am trying to modify the value. I am trying to modify, like saying that B is equal to B minus 50. I tried modifying, it is modified, and then write B. I am changing the value. Unlock B, that means I am releasing the lock from data item B. After some time here, you have one more. In transaction T2, you are working on a data item called as A. So we applied shared mode on this particular data item. You read the data item, and then you released log from the data item A. After that, what did you do? You're working on data item which is B, which is already modified in T1. Okay, so when it is modified in T1 here, we have written it to the hard disk and we released the log. So we can read here, there is no problem in reading the same data item in another transaction called T2, because here the lock is released. Though it was in exclusive lock, you are able to read because the lock is released. That means there is no lock at all here. Okay, so you are able to read the value called B and you unlock even B. Before this, you will be locking it in shared mode. So you unlocked even B and then display the value of A plus B, sum of A and B. That will be sum. After this, what did you do? You performed in transaction T1, you performed exclusive lock on data item A. So when you are performing exclusive lock, you will be performing both the read and write operations. So you are reading first of all, later on you are modifying and then writing and then releasing the log. So what is happening here? This is a non-serial schedule, obviously. When you don't apply these particular locks here, you will have a non-serial schedule and we could not know what will happen at what time. As such, the serializability can be achieved. But as you are performing certain things here, like modifying, then in that case you will be able, because it is a non-serial schedule, but we applied locks here. As such, we are able to get a we are able to achieve serializability. This is what happens in your non-serial schedules, and by using log-based protocols, we will achieve serializability. Is this clear? So, one of the log-based protocols is two-phase locking protocol, which is said to be a basic 2PL or rigorous 2. Okay, this is used to ensure conflict serializable schedules. So this protocol will be in two phases. One is growing phase and shrinking phase. Okay, when you say it's a growing phase, here in the growing phase, the transaction will obtain all the locks and it may not release locks. And in shrinking phase, it will release locks and will not obtain any locks. So transactions can perform read and write between these locks now. So if at all, if you wanted to explain something like this, it is, see, this particular two-phase locking protocol is entirely dealt with the growing phase and shrinking phase. Now here you will be applying locks like this. So when you are applying locks like this particular thing from this is said to be a growing phase. Is this clear? And from here to here, it is said to be a shrinking phase. That means here you have acquired lock. Now you should release the lock. Now you should release the lock. First, whichever is acquired last will be released first, and then this, and then this. This is the way how you are releasing the locks. Okay, so now this phase is said to be the growing phase, and this particular phase is said to be the shrinking phase. And the top point, this peak point, is called as lock point. This is the point. We can, at this point we can say that the transaction has acquired its final lock. That means whenever the transaction has reached to this lock point, that means the transaction has reached to its final lock. And the next procedure for the transaction to perform is to release the lock, because it has reached the lock point. After lock point, again it has to go down. That is called as shrinking phase. So here what will happen? It will be releasing all the locks. Here in no way it will acquire locks in shrinking phase, and in growing phase in no way it will release locks. Here it should only attain locks, and here it should only release locks. That is what happens in two-phase locking protocol. This is one type of locking protocol. Okay, so if you can look at the example here, if you can look at the example, what happens is for transaction T1, you are providing an exclusive lock on data item B, and then you are reading it, fine, you are modifying, you are writing it, and then again on lock on data item A, same exclusive lock, you are reading, you are writing. We did not unlock here. Two-phase locking protocol, we did not unlock here. So the one which A is equal to A plus 50 and write off A, so the data is written. First, it has acquired lock on B, so it is unlocking B, and it has acquired lock on A, so it is unlocking A. Okay, so this will generate irrecoverable schedules and cascading rollbacks. This may generate, and this will not ensure freedom from deadlock. This is how the two-phase locking protocol, one of the locking protocols, that is two-phase locking protocols, is performed. Okay, so here till here we can say that it is a growing phase, and here we can say that it is shrinking. And the very most important thing to be understood here is dirty read. Dirty read is nothing but, see, if you consider these two transactions here, you have read some data item A, okay, and it has written. After it has written, the job of A is finished. That means transaction T8 has to commit here. Only then if it commits, then only it will be reaching to the hard disk. Yes or no? Without committing, if you are going to read the same data item from T8 in T9 and then you commit here, now this particular operation, this read operation is said to be a dirty read operation. Dirty read is an operation which is performing the reading operation in another transaction before it gets committed in its previous transaction. That is said to be dirty read. So when a transaction is allowed to read in such a way which is not committed yet, then dirty, we say that it's a dirty read, and dirty read occurs. Okay, so the two-phase locking protocols is something like this. See, dirty read, if you wanted to understand, in two-phase locking protocol there is a problem of dirty read. Before it is getting committed here, you started giving shared lock on data item A and you are trying to read here. This is said to be an irrecoverable schedule. When there is a dirty read in any transaction, that is said to be an irrecoverable schedule. And when you consider deadlock when you consider, say you are performing lock on shared lock on A, you are reading, you did not commit it yet. You are performing exclusive lock on B, you are reading, you are writing. Okay. After that, you are performing exclusive shared lock on B and you are performing exclusive lock on A. Okay. You are performing exclusive lock on A. What will happen now? This is said to be deadlock because you wanted exclusive lock on B, but this is not committed yet. Here lock is not released. You are trying to acquire exclusive lock on A here, which is not possible. So in two-phase locking protocol, there will be deadlock. Deadlock is occurred in two-phase locking protocol. These are two different problems. Dirty read problem and deadlock is occurred in two-phase locking protocol. There is one more protocol called as strict two-phase locking protocol. Here in strict two-phase, what will happen is in the shrinking phase, unlocking of exclusive locks are not allowed, but unlocking of shared locks can be done. So unlocking of exclusive locks are not allowed in strict two-phase, but unlocking of shared locks can be allowed, and in strict two-phase locking protocol, you don't have dirty reads, we can avoid them, but we'll have the problem of deadlock, which we have seen earlier. Okay, so this is what is about lock-based protocol, and this is what happens. These are the different types of lock-based protocols, and these are the problems which are faced by lock-based, two different lock-based protocols. Is this clear? Hope everything is clear. Thank you.